They're two good friends, and they're starting here on County Q Road. So let's say they're right about here. There's Pon&Ton, and they're walking this way on County Q. But then Pon says, Ton, why don't we cut over to straight line? Maybe it's faster. Okay, so let's illustrate that. Cutting over to straight line. So you take the B line distance, that is, it's the perpendicular distance down here like this. That would be the shortest distance from the point not on line to the line itself. Okay. Now they proceed, but they get to a straight line that takes it's exactly 1 mile. 1 mile moving along that through the desert. But then John says that was a good idea, but I find straight line to be just as long as county line, so let's take the shortest back to County Q. So now in our next step, now they're going to start heading back to County Q. So now you have to take the perpendicular distance like this. And this begins the little zigzag journey. I'm going to show you how to record it on GeoGebra. Yeah, this view. It's under view. We don't want the axes. So there you go. That's cleaned up. And now let's make our two roads. And that's going to be aligned. So we want to make a, and this will be our first line. There you go. We got A and B. Put this over here like this. Coffee shop. So the coffee shop doesn't keep moving around, but we're going to be able to adjust the lines. Now let's make our other line. We can get some coffee. Now it's good to test to make sure your stuff is doing okay here. And that is, I can move this point around, I can move this point around. We can also measure the angle here between these guys. We can click on 3 points. And it tells us that we're at 48 degrees right now between the two. And like I say in the problem, it might help if you keep it less than 45. So there we are at 42. So first of all, make sure you put these points, that C point and A point well away, because we want to be able to change the lines later on. But right now, let's put a point actually on, and we're going to call that the starting point. Okay, here's our starting point. Here's Ton sitting on the, going back and forth, Pon&Ton. And we want to get a perpendicular line from the starting point to this. So go to perpendicular, hit the starting point, and a line, that creates a perpendicular line. Now we want to actually find that intersection. So you hop over here to intersection, which is under this menu. Might look like new point here. Click both these, and that's the intersection. And now they're on the other road. Now to get back to the other road now, we go back to, okay, here I've done 1, 2, 3, 4, 5, 6, 7 little trips. We're supposed to have 10. And it's getting a little cramped in there. So here's why I said, hey, make sure these are all sliders. So go back to your selection tool. And notice you can get a little more space by sliding the starting point back a bit. But you get a lot more space by moving this line down. See, that really opens up spaces there. By making the angle between the two rows less, you have a lot more room. So I'm going to continue now until I get 10. Okay, that's 10 lines now. And notice it's giving me all this information on the equations of all these lines, which we don't really need for our problem. What we need is the distances. Okay? So I want to create the line segments between these. So go to my segment tool and create a bunch of line segments from starting point to B, from B to D, D to E, there you go, E to F, F to G, G to H, H to I to J, J to K, and K to L. And now you got all sorts of lengths here. And those are all listed down here. Should be 10 lengths, I think it must have restarted the count. Now, if you want to, you can go along and select all these lines and hide them. Let me show you how to do that, just so it cleans up the diagram a little bit. You go to this, you select the line, you go to Object Properties, and just go like this, don't show the object. Okay? So I'm going to repeat that process on the rest. I was able to do that a lot faster by using the Control key to click on more than one thing at once. And then come up here, under Edit, you can select all the object properties at once. And notice I did miss one of the segments, so let's get that patched up. Go to our segment tool and get the segment from G to H. There we go. Now I want to focus on all those distances. And so you should be able to highlight all those. We still have all these equations in here and a lot of stuff that we don't want. We just want to come up with the distances. And look up where those are on here. Okay, I just found a good way to find out where all these distances are here. And that is to go along and select each one. Select them all. Hit the Control key so I can select multiples. Selecting all of them. And then come on over to Object Properties. And let's make them all red. And then we'll be able to spot them. Okay. There, now we can see where they are in our whole jumble up here. And we want that. Notice how it makes a nice decreasing progression here of distances. Actually, the distances are all kind of jumbled up, but we can see that this distance here, right, is our starting distance. And we should have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 distances. And there's a little trick you can do up here, and that's under measurement, and that's to do a summing up of all those. We can do that over here. Under input equals this distance, A1, okay, here's how you enter them then. I figured out that N was my first one just by turning on and off. And so we just enter the letters N plus P plus Q plus R plus S plus T plus, and by copying it I was able to see how to get the subscripts. You have to go A and then underscore 1 plus B underscore 1 plus C underscore 1 plus D underscore 1. And now that should add up to 10 distances. And it does, and it puts it under this thing called O. 20.6 is our total length. And now we can change that total length by moving A around, right? And as you can see, O gets a lot, well, small in this case because I'm kind of angling down like that. Now it seems to be getting bigger again. You can change the starting point. You can shrink it like that. As you can see, there's probably a few more distances I could do in here. So this is just going to give us a very rough estimate of the distance. So let's do something like that, where it looks like I've got a minimum amount of stuff left over. There we go, I'm at like 50 degrees or so. There you go, 45 degrees. Well, as I said, let's get a little under. There you go, 44.6 degrees. Okay, now that still doesn't prorate the whole distance though, because our first distance here, N, is 5.85. Right, 5.85. So basically we can get it into the right scaling by just taking our total distance O, and dividing it by the first distance. And that'll get everything in terms of 1 mile for the first distance. So that first distance was N. That's our U, 3.35. So if the first section was 1, then this whole trip took Pon&Ton 3.35. Now you've got to work on the geometry of coming up with an exact equation for this total distance traveled. And let's go back to the scratch board for that. What we need to do is look at a specific line. All right, so we want to get Pon&Ton's distance in terms of this first length that they do. Come down here like this. That's the perpendicular. That's called length 1. And this angle theta. And we're going to get the total distance in terms of just these two variables. The first distance and the angle between. Well, here's our second length like this. And maybe we can see a relationship between length 2 and length 1 will be all set. How does this angle show up in here? Well, if we look at it, this is also right angle, and so this is 90 minus theta, and then so that means the angle in here is actually theta. Let's check that on our GeoGebra diagram by doing a measurement. We want to see if this angle is the same as 44.6 degrees. So let's go to measure, and we'll measure it by those 3 points. That one, that one, that one. 314.32. Well, actually, it's giving it the complement. And if you add 42 in there, 44.68, notice you get 360. So yeah, those angles are congruent. Great. So, getting back to the pictures again. That is theta in there. And now what's the trig relationship between these two sides? In this right triangle here, this first little right triangle, let's emphasize that in blue here. If I just look at this right triangle now, focus on it. Just this right triangle. You've got length 1, length 2, and theta. And for trigonometry, remember what this is called? Hypotenuse. And this is the adjacent side. Ha ha ha. No. Sokatoa, ka, cosine. The cosine of theta equals the adjacent side L2 over the hypotenuse L1. So L2 equals L1 times the cosine of theta. And I think you're going to see that this continues that for L3, when we come down here and make a new triangle, like this to form L3 here. Now L2 takes the role of the hypotenuse and L3 is the short leg. So that L3 will equal L2 times the cosine of theta. And so forth. L4, the length 4 will equal L3 times the cosine of theta. So we form a sequence L1, L1 cosine theta, L3, which is L2 times cosine theta, becomes L1 times cosine theta squared. And you end up with a geometric series because you're adding them all up. Geometric series where the first term is L1 and the common ratio is cosine theta. And if you remember the formula for an infinite geometric series, I was looking for. Now what you need to do is plug this in, see how it works in yours, see how well it works to predict the overall length. And then why isn't it perfect? Why is the sum you came up with different than this infinite sum? Okay, flange out.